Good afternoon, each and everyone. I hope I am audible to all of you. Amar,
Yes,
can you please confirm?
yes, Irfan, you're audible.
Yeah, thank you. So we have just crossed 500. So let us start with the introduction. So I heartily welcome all the participants, faculty participants for this National Faculty Development Program on deep learning and artificial intelligence. Let me remind you that we have started this FDP series on 13th of November. So on 13th of November to 17th of November 2023, we have finished with machine learning and artificial intelligence, which was the FDP AI FDP series, first series. Second FDP program we conducted on 4th December, from 4th December to 8th of December 2023 on NLP and computer vision plus AI. And now we are at the third FDP of that series, which is on deep learning and artificial intelligence. So this is the quick reminder for you. Now, here I would like to request all the faculty participants, please, you can ask your colleague, friends to join the session at their earliest convenience so that we can start the session on time. And if anybody is getting technical glitch to get into the Zoom, they can also switch to YouTube platform. We are also live on YouTube as well. So yeah, those who are getting problem or technical glitch while getting into this Zoom, they are suggested to switch to YouTube live. All right. So my name is Irfan. I'm a senior manager heading EDL MOU department at XLR. I again heartily welcome to all the professors who join in here for this National Faculty Development Program on Deep Learning and Artificial Intelligence Series 3. Now, I would welcome today's guests. Rather, we are conducting this National Faculty Development Program on Deep Learning and Artificial Intelligence in collaboration with APSSDC. So from APSSDC, we have with us Dr. Ravi Gujula sir, who is a CGM technical head at APSSDC. Second guest, we have with us Mr. Amit Saha, who is associate director from XLR. Now I would like to request Dr. Ravi sir, please guide faculties on this National Faculty Development Program on Deep Learning and AI. Over to you, Ravi sir.
Yeah, Irfan, very good afternoon and thank you very much. And thanks to Amit, who is in online, Director XLR. And very good afternoon to all the faculty members who are enrolled for this program. So really, it's a great privilege to stand in, to talk about this importance of faculty development program, how APSSDC collaborated with XLR. So as Irfan earlier mentioned, this is a faculty development program series. This is a third one. So before prior to this faculty development program, there is a faculty development program series 1, AI with ML, one program completed and it's a huge success and there are many faculty members participated. On the faculty development program series 2, AI with NLP and computer vision successfully completed. And now it's time for deep learning and artificial intelligence. this program from today to 1st of March 2024. So basically, the XLR bringing the subject matter experts from the industry to train our faculty members on this disruptive technology. The main objective is to make the faculty talent pool across the nation. So where XLR collaborated with Andhra Pradesh State Skill Development Corporation to make the faculty talented pool in AI domain. So the main basic idea of Andhra Pradesh government is to make our faculty members experts in artificial intelligence in a topics like AI, ML, deep learning, computer vision, NLP, natural language processing, and many more, which is not limited to only this one. And so we continuously organizing this kind of faculty development programs across the entire year. So one is to provide a good quality of teaching to the students by the faculty members in that aspect. And the second thing is we want to make the more research proposal from Andhra Pradesh state faculty. So when the faculty are absolutely, I mean, perfect in the domains and creating new product development using this technology. So that's what we are focusing more on faculty development program, so that faculty will come up with a different ideas. They can submit to the DST, Department of Science and Technology. So they get funding from DST, and then they can execute the projects at college or university level with faculty and combination of with faculty and the students. So that is the main objective. And also the other main objective of conducting faculty development program is, as you know, all the faculty members, earlier computer science is the only one branch, but now today uh, CSC with the data science, CSC with the AI, ML, CSC with the cyber security, CSC branch with the IoT. So these all new branches, allied branches came up in a computer science. So this is our need of hour to train our faculty members on these latest technology. So where we collaborated with XLR, because XLR have experience and they executed many projects at corporate level. So our main ultimate objective is to make uh, to teach in an application oriented teaching in the faculty development program, so that the faculty able to understand the concepts and they can create a new projects on artificial intelligence. So that is the main objective. I request all the faculty members utilize this great opportunity for you and actively participate. And the session is supposed to be more interactive, as we are working with Irfan and Amit. It's like they are encouraging the faculty to ask more questions and to get it clarify the doubts from there itself. So I hope so. I congratulate all the faculty members who are registered for this program and attend regularly and make it a grand success. Thank you very much. And once again, thanks a lot for all the faculty members who were registered. And big thanks to XLR team, Amit and Irfan and other team of XLR. Thank you very much, Irfan. Over to you.
Yeah. Thank you so much, sir. And rather, I would like to express my deepest gratitude to you, sir, for your unwavering support and partnership in organizing this national level faculty development program on entire series. And truly, your commitment to the academic excellence and technological advancement has been truly instrumental in making this national FDP program a reality. Thank you so much, sir. From XLR, we have with us today. Yeah, thank you. From XLR, we have with us today our Associate Director, Mr. Amit Saha. And now I would like to request Mr. Amit Saha, please light on our EDL, Everyday Learning Program, right from the MOU and other institutional association products. Over to you, Amit sir.
Thank you so much, Irfan. Hope I am audible.
Yes, you're audible.
Yeah, so very, very good afternoon and a warm welcome to all the eminent guests from the academia who has joined in today for this session and would be with us in this journey for the coming days. Before I move on to sharing the experiences with reference to what XLR, the journey of XLR that we have been through. I would definitely would like to extend a warm thank you to Dr. Ravi Gujala, uh, Dr. Vinod Kumar, MD and CEO of APSSDC, and the entire core team of APSSDC for the kind of initiative they have taken, because of which they are being able to also reap the benefits. I would like to extend this more quantitatively. That is, if some of you who might have been able to get access to the recent India Skills report, uh, the state of Andhra Pradesh, and those of you who are representing from Andhra Pradesh, which I understand is probably the major part of the gathering today, you would be really feeling so proud of, leading that particular table of the number of learners that APSSDC or as a state has been able to mobilize on this aspect. And I think a major part of the credit goes to the flag bearers like APSSDC and the think tank who are who are who have taken that pains to take it up to this particular level. As we normally has a saying that whatever you reap is based on what you sow. So I think it is it is basically a benchmark, the trend setting that the state of AP has done, which many of the other states, I know specifically that many of the other states are trying to get the insights and create their own roadmap, considering the state of Andhra Pradesh's success story as the benchmark. So again, once more, congratulations to the APSSDC team to you know create that success story through a proper laid out action plan. On that note, uh, as already our good old friend Dr. Ravi Gujala has already mentioned that in those pragmatic steps, XLR has also been extending whatever limited support that we are capable of in mobilizing and channelizing and for execution of such kind of training and delivery models. Faculty development program, I think, is one of the most essential factors as far as the real internal growth that the academia can look for, because end of the day, the graduating youths will be spending majority of their time during their formative years with the faculty members in the college. So if more and more initiatives are taken on training and enabling the faculty members, I think half the war is won there itself. So we and APSSDC had been taking initiatives, proactive initiatives, I would say, over the last 2 years in trying to bring forth the opportunities for the faculty for engaging themselves in the emerging technology areas, garner the insights from the industry experts, like one of those experts who would be there with us today. And through those enablement, they go out there with full confidence in executing or proliferating that education amongst their students. So a very quick journey of XLR, I would like to take you through. So I hope my screen is visible. Irfan, if you can just quickly confirm once.
Yes, Amit, it is visible.
Fantastic. So XLR, as you see, the catch line itself, raising excellence. So we are always striving for excellence. And right from a journey which started off around late 2013, 14, early 2014, as an initiative of IIT, IM, and ISB alumni, we have traversed that path of enabling close to around 4 lakh plus learners over this period of last 10 years. We have also created our global footprint, not only across India, but across multiple other nations across the globe. We have been successfully enabling close to around 450 plus corporate organizations in being associated with them for the workforce upskilling. And also, very recently, we have crossed close to around 1,200 plus MOUs with the higher education institutions of the country and few of from the international universities as well. Some of the benchmarks that we have been able to create over these last 18 months of imparting close to around 1,000 plus hours of student development programs and 1,000 plus hours of faculty development programs, absolutely free of cost. Some of the premium academic partners, I'm pretty sure all of you are out here, so please don't get discouraged or offended by few of the names that are highlighted out here, because it is just for the sake of space. We have just put in some of the premium associations that we have. Two of the premium associations which we have been able to coin uh, just about this particular quarter, that is from Jan to March, that is IIT Roorkee and IIT Bombay. Uh, BITS Pilani, where we have been doing consistent in-campus training deliveries, and some of the other premium institutions spread across the country. As far as the skill bodies are concerned, we have recently collaborated with iHub Divya Sampark, which is a joint initiative of IIT Roorkee and Government of India, Department of Science and Technology. At a state level, of course, our partners in this delivery, partners in this expansion, that is APSSDC, APSCHE, TASK in Telangana, and KMDC in Karnataka. We are in ongoing discussion with Karnataka in digital economy missions of Karnataka and Kerala as well. Of course, along with our work, we also got the due recognitions also from Deloitte, Silicon India, Analytics India, and so on. We're also the prime partners of NASCOM skills program as well. Some of our recent engagements, which we had in the last quarter, being the training imparted with BITS Pilani on Power BI and machine learning for the final year students, and which came from multiple departments, not only departments related to engineering and computer science. It was a great mix of close to around 450 students. The year end, when everybody was awaiting for welcoming 2024, we were at the IIT Roorkee campus imparting training to a selected group of research scholars on data analytics using a platform called Minitab, with an industry expert as who is the principal data scientist working with Accenture. Similarly, in the month of January, we had imparted a full stack development training with the faculty members of IIT Bombay. You might be having a quick concern why IIT Bombay faculty require this kind of training. Is because they are definitely the masters as far as the technology is concerned. But again, they also felt that they require upgradations or updations with reference to how industry implementations are being done and the change of versions, change or updations are happening in the industry on the similar technology. So see, as far as progressive institutions are concerned, the top tier institutions are also looking for similar engagement. So naturally, I think this is the call of the hour for all the institutions or higher education institutions spread across the country today. These are overall not an exhaustive list, but some of the primary programs in which we are involved, primarily in the emerging technology area. As everyday learning, we provide a space for learning for students through the SDP programs, for the faculty members, for the FDP programs, and as well as we do student orientation sessions for the general counseling and awareness creation as a platform, so that the institute can take up this advantage and make their students more aware about the technology interventions, the disruptive interventions that are happening in the technology space. So we are having an exhaustive platform. I would say that key highlighters on these programs, whether it is an SDP, FDP, or the student orientation services, are that we handpick our trainers from the practicing industry practitioners, industry experts. That creates the primary differentiator. We provide everything as a lifelong learning in the form of a lifetime LMS access that are provided to them. And of course, they can also try, each and every person can also have a quick assessment of their uh, practice and enablement of the use of the technology they learn through the assignments and assessments that are provided in the platform. There is a basic highlighter with reference to the elements they can use. And finally, they culminate with the certification from XLR. And now the certifications will be extended as a joint certification from XLR and APSSDC, and nationally as XLR and iHub Divya Sampark, which is a joint initiative of IIT Roorkee and Department of Science and Technology, Government of India. We also have certain paid programs. Of course, we require the fuel to run because we are not an externally funded, but a for-profit organization. But this is a CSR wing of ours, where we provide the free platform for every learner, whether it is a student or a faculty. But we also have paid programs at 7 locations across the country. So these are the different 7 locations where we are having our physical presence in Mumbai, in Andheri and Thane, in Pune. We are being there in Baner and Viman Nagar. In Hyderabad, we are there in Cybertaz. In Bangalore, which happens to be our headquarters, where we have recently launched our second location. So our head office being at BTM, second location we have launched in Marathali, and also we have started our operations in Chennai. Some of the marquee corporate partners who are associated with us both for the engagement for their current workforce upskilling, and as well as recruitment partners with us. We have almost close to around 5,000 plus corporates who are associated with us as recruitment partners. And recently, we have extended our free platform through launching of a disruptive program, which is the need of the hour, that is through Skill Up Final Years. It's a first of its kind campus recruitment training program, which is imparted absolutely free of cost for campus interview success. Not only we are providing the training, we are adding it up as for the end result, what we call as the result orientation or the ultimate outcome base, that is the free placement assistance also. So in the first engagement itself on 8th January, we started off with 10,500 candidates who joined this program. And I am really very excited to share with you, as we stand on today's date, we are having close to around 51,000 candidates who are availing this program through our platform, majorly spread across the tier 2 and tier 3 locations of the country. And of course, Andhra Pradesh as a state, again, leading that particular drive, where close to around 30% of these 50,000 students are represented from the students of Andhra Pradesh. So what we do in the CRT program, we provide a 200 plus hours of coding skills, quantitative aptitude, logical reasoning, verbal ability, soft skills, resume builder and LinkedIn profiling, techniques to ace group discussions and personal interview, through multi-set of delivery modules related to live online sessions, self-learning program through the LMS, assignments, and as well as competitive exams or tests which are conducted at subject level, and as well as a final aptitude test, including all the segments that I had discussed in this particular slide. Not only that, we are also recognizing their efforts of participation through cash rewards. In the first assessment that was taken for the at a subject level conducted on 17th of February for logical reasoning, we have selected, handpicked close to around 40 plus candidates and awarded them with the cash rewards. Similarly, in the forthcoming days also, for the other sections also, we will be having subject level tests, and also, as I said, for the uh, full full length aptitude test that would be conducted. No, the whole chapter doesn't ends there. That's only a curtain raiser for the final lap. That is, after doing the proper screening, the screened candidates or the shortlisted candidates would also be provided by our placement team as a placement assistance support, where our team is working with 5,000 plus hiring partners based on the buckets of requirement that they create. We will be conducting placement drives in multiple formats, whether it is job fairs, offline, online, hybrid. We will be conducting it between May to September 2024. On the screen, as you see, we have provided with the registration QR code, and as well as a robust WhatsApp channel. If any one of you yet are not members of it, please take a pic of this particular slide and also share it across to your students. I'm I can guarantee you that you would be doing a great favor to them by making them a part of this community of availing the Skill Up program, and as well as being a part of this WhatsApp community to get continuous updates of the recent happenings and developments in the emerging technology space. So with that, I would like to introduce to you Mr. Vikas Narune, who is going to be the subject matter expert who would be uh, handling this particular session on deep learning with AI. And when I was having a discussion, if I recall, in the month of end of November 2023, the plan was basically providing an exhaustive faculty development program module on artificial intelligence. And after a lot of brainstorming, we planned that let us break it up into modular formats so that it doesn't become too exhaustive. At the same time, there are short-term goals which are achieved from each of these modules. So as Dr. Ravi has already mentioned to you, we started off with the module on machine learning, moved over to NLP and deep learning. And then today we are starting off with NLP and computer vision in the last program. And today we are starting off with the deep learning module. And finally, we will end up with the last module, which will subsequently come in. We will declare the dates as well very shortly to you all, where we'll culminate with the industry case studies. And finally, we will complete this particular module. So all of you who have been already a part of this journey, please continue being the same. Also spread this message across to your peers, your friends in the academia, those who are yet to join this program. Let them take the benefit of it by becoming a part of this particular journey. So Mr. Vikas Narune, being a corporate trainer and a data scientist, specializing in Google Cloud, big data, and machine learning fundamentals, and who has got the training. I mean, he has imparted training to a huge number of learners, both students and corporate, employees, and as well as the faculty across the country, and who is also specialized in quality management system and audits for the same. And currently, he being a director of applied AI at an MNC. So I'm sure many of you who had already enjoyed multiple sessions, multiple training modules along with him. You had a very highly engaging journey with him. So, on that note, I would like to hand over the podium to Vikas sir. Vikas sir, please take over the dais and enlighten the audience with with their journey in deep learning with AI. Thank you very much, all of you. Have a great time with us.
Thank you, Amit. I guess we will be having the LMS session first, then we will continue.
Oh, I'm extremely sorry. I'm extremely sorry. So yeah, before we move on, probably yes, I would request Amar to please take over and take everybody through the through the LMS kit.
Yes, Amit.
Yeah.
Thank you, Amit.
Uh,
Yes.
Yeah.
Yeah, I think
Chandana.
Chandana, you would be taking
Yeah.
up the session, right?
Okay. Yeah.
Yes, I'm taking.
Okay. Yeah. So Chandana would be taking you through this session.
Yeah, thank you, Amit. So, good afternoon, everyone. A warm welcome to our National Faculty Development Program on Deep Learning and Artificial Intelligence. Before going to the LMSKT, I hope everyone registered for this Deep Learning and Artificial Intelligence. If not, I will share the registration link after the KT. You can register for that. Okay. So, yes, I hope my screen is visible. Let me know in the chat box.
Yes, Chandana, it's visible.
Yeah, thank you, Amar. So LMS, what is LMS? LMS is a learning management system. It's a XLR's e-learning portal. In this LMS, you will get all the stuffs like recording sessions, feedback links, materials, and more. Okay. And one more important thing, this LMS will be with you lifetime. You can access at any time. Okay. So after registration, you will receive two mails. So one is verification mail. So you can see here, welcome to XLR mail. So here we have a verification link. Just click on this link. So it will take you to set your password page. So here we have a password. So create your password and confirm the same password here and click on set my password. So you are set your password done. So after that, we'll go to the second mail. So that is a course invitation mail. So you can see welcome to the National Faculty Development Program on Deep Learning and Artificial Intelligence. Yes, so here we have a registration link, that is the onlinelearning.xlr.com. So just click on this link, it will take you to sign in page. So here you can see register, store and sign in. So we already registered for this course, so no need to register again. So store I will explain you about later. Okay, so sign in, just click on this sign in. So it will take you to login page. So this is our login page. Here we have a email ID and password. So whatever you registered, whatever with the email ID you registered, so mention that email ID here. And previously you set your password, right? So that password you have to mention here. Just click on this login. So it will take you to home page. So from here, I would like to explain this LMS KT to the live. So you will understand better than this PPT. Just give me a couple of minutes. I will reshare my screen. Hope my screen is visible.
Yes,
Amar? Yeah. Yeah, thank you. So here, make sure we are in a home page. So here we have two parts like a left side and right side. First, I will explain about right side. So you can see here one YouTube thumbnail and coming to down, you can see here today's session. So let me refresh it. Yep. Yeah. Now you can see here National Faculty Development Program on Deep Learning and Artificial Intelligence Day 1. So exactly at 2:50, you can see here join button. Click on this join button. It will take you to Zoom session. If you have any technical glitch with Zoom session, you can go through the YouTube live. So if you click on this YouTube thumbnail, it will take you to YouTube live. Okay, so I'm done with this right side. So coming to left side, so I registered for many programs, so that's why it is showing like this. So now I register for National Faculty Development Program on Deep Learning and Artificial Intelligence. Yes, I got here. Just click on this tab. Yeah. So now here it came curriculum page. Yes. So this is our curriculum page. Here we can see feedback, response, session recordings, and materials. Daily you can give your response. You can give attendance from here also. So coming to feedback response, why it is important? Yes, daily you have to mark your attendance so that you can get certificate. 60% attendance is mandatory for the certificate. Without attendance, we are not giving the certificate. Okay. So session recordings daily. So we started with day one. So you can see the recording day one from here. So after completing all the programs, you can see all 5 days from here. Okay. So materials which are Vikas told explained in the session. So those materials we will upload here. You can get from here. Okay. So yes, my library, you can see the curriculum. So I told that I will explain about store as well, right? So here we have in a store, we can see many programs which are happened previously. So you can go through this, you can enroll from here and you can see these recordings. By watching these recording programs, you can't get a certificate. You have to watch a live sessions and you have to mark attendance. So that time you can receive certificate. By watching recording sessions, you won't get it. So I hope my LMS gate is clear. If you have any queries also, I will clear at last 10 minutes. Yep, thank you.
So thank you, Chandana. Hope I am audible to everyone. Can you
Yes,
please confirm?
because you are audible.
Yeah, thank you. Let me share my screen, guys, and then we can start. So meanwhile, hello everyone. I am Vikas. So Amit has already introduced me. First of all, I would like to thank APSSDC and XLR for giving me this opportunity to present one more session with you guys. So you guys were always amazing in terms of the contribution, in terms of the enthusiasm you guys are already showing. So let's hope that this session also will make it very exciting like the previous one. And I hope now everyone is able to see my screen as well. Okay. So guys, quickly in the chat box, if I can confirm that you can hear me properly, you are able to see my screen, so we can get started then. All right.
Yes, it's visible.
Yeah, thank you, Dr. Kirti, Aditya Kumar sir. Thank you, everyone. Thanks for the confirmation, and let's get started then. So guys, what you can expect from this series and what we will cover. Siddharth Ghosh sir, thank you. Ram sir, thank you, everyone. So let's try to discuss the agenda for today. All right. So today what we gonna start and what we'll be going through towards this session is like we'll try to understand about the artificial neural network. Dharam sir, thank you very much. Nice to see you again. Guys, meanwhile, when I'm trying to deliver the session, if you have any queries, any questions, you can also chat with me in the chat box. I'll try to take a couple of question as well simultaneously. And then we can focus on the session as well along with it. So today we're going to start with the artificial neural network. We'll try to understand what is deep learning and how this artificial neural network artificial neural network will be connected to the deep learning, which one of the technique for the deep learning. And then we'll try to dive into this one. What is ANN? What is the entire structure look like? How it is associated with the entire human brain and how the things, since we already seen that entire thing when we try to talk about the artificial intelligence, right? So it is it is a just exact copy of the human brain and let's say neural networks of the humans, chemical neural networks, which exist, biological one. And we'll try to connect the similarity between the ANN and the human brain, or let's say biological neural network. how the working has been copied, how they were able to successfully get these things done. And then we'll try to deep dive into these things like what is called as perceptron, what is multi-layer perceptron, what exactly happens in the artificial neural network, what kind of a process happen, what are the activation function, what are the cost function, and how the entire processing happens in the background, and how we are able to get the prediction out of it. And then we obviously will try to talk about some of the disadvantage and learning technique like forward propagation, back propagation, along with it what is vanishing gradient and exploring gradient. And then we'll try to talk about how to regularize this kind of issues by using dropout layer. So that's going to be agenda so for coming 2 days or 3 days, and then we'll try to go into detail also along with the use case. So we'll try to solve one use case along by building our own architecture of the artificial neural network, and we'll try to solve one use case, and maybe we'll try to take two data. One is structured and one is unstructured, and let's see how we are able to build our own architecture and be able to execute this in practical manner as well. So hope you guys are comfortable with the agenda, so I can start moving forward. So let's try to first focus here, and we'll try to compare how the artificial neural network is exactly copied and what is the similarity between the human brain and the artificial neural network. And then probably once we understand what is deep learning and what the ANN is playing role out here, so we'll try to understand one roadmap, which will be the end-to-end roadmap for this deep learning expert, AI expert. And if possible, on the last day, we will try to talk about the things. We'll try to talk about the current let me share my screen. We'll try to talk about the current scenario in the market, which is about the generative AI. So we'll try to highlight some of the topics as well in the generative AI and how the generative AI is impacting the entire field, right? This is what we will try to talk about. So prior to that, let me go back to the previous screen and let's try to understand the discussion. Guys, meanwhile, everyone, if you feel that, Gokila Priya ma'am is asking in homepage, I did not get any updates for registers today. Okay, ma'am, my colleague will help you. Amar and Chandana can help you on this one. So guys, let's get started. Hope you guys are excited, and just give me kind of a thumbs up or kind of a confirmation, guys. If everyone is comfortable with the agenda, and we can go ahead then. Already received couple of confirmation. Yeah, a few more, and that will be great. Okay, thank you, Kirti ma'am. Thank you, Kunal. Vidya ma'am, thank you. Okay, let's get started then. Okay, so thank you everyone. Thanks for the confirmation. So let's try to understand here what we are exactly trying to achieve today. Okay, Dharam sir, thank you. So guys, when we're trying to talk about the deep learning, okay, so let me draw this our favorite diagram where we try to connect actually everything to the artificial neural network. So when I'm trying to talk about the AI, right, artificial neural network, AI means we are trying to put intelligence into the machines artificially, right? Because the machines are not inborn talented, so they don't have a brain. We are trying to give a brain to them in single words and trying to make the machine work like the human beings, right? That is what the AI is all about. Within the AI, guys, if AI is considered as a universe, within that universe, we have a parallel earths. You can call it as this parallel earth could be something like that. First parallel earth will be a machine learning, and within that parallel earth, we have a one country, which I will say deep learning, correct? So just to put it in simple terms, so deep learning is a subset of machine learning, which is also a part of the artificial intelligence, right? So why I'm trying to showcase you this, just to make sure that we are trying to connect where this deep learning coming from, right? So deep learning, so what exactly when I'm trying to bifurcate the deep learning and when we trying to understand, or whenever we go ahead, let me rub these things or let it be, we can understand few more concept into the deep learning. And then once we are clear that why exactly deep learning is different from machine learning, we can try to discuss this diagram. Okay, so let's try to understand what we are trying to achieve here. So if I am trying to talk about the deep learning and if I try to talk about the machine learning as well, right, simultaneously, how can I bifurcate and how can I understand what is the difference between them? So first and foremost difference which you should understand is about the data. So the kind of a data we are trying to process out here within the deep learning and the kind of a data we are trying to process in the machine learning is somewhat different in terms of the structures, right? So guys, when I'm trying to talk about the structures means structured and unstructured data. So when I try to talk about the deep learning, we are trying to process here the unstructured data, unstructured one. Hope my handwriting is readable, and sorry for that if it is not that great, but I guess it is readable. And when we're trying to talk about the data in the machine learning, it is mostly the structured one. So guys, can anyone tell me the difference between structured and unstructured data quickly? So before we try to jump into the discussion that how the deep learning is different and making it exclusive for the use cases apart from the machine learning. So table format, great. So table format is a structured one. No current positions, okay. Text, yeah, text, is it belong to structured or unstructured? Structured data, table format, structured data is label format. Thank you, sir. Thank you, ma'am, for your answers. Yeah, unstructured, great. So guys, when I'm trying to talk about the structured data, I can simply draw this diagram. Structured data means which can be fitted into rows and columns, right? So where we can create this kind of a diagram. Awesome. Dr. R. Tamil Kodi sir, thank you. You are awesome. Your answer. Structured data, yeah, Murli Krishnan. Awesome explanation. Yeah, guys. Thank you very much, guys. Mangaldi, awesome. You guys are really fantastic. I'm getting a lot of explanations. So, all right, great, guys. You are correct. So, what we can, yeah, Sahil Sheikh, thank you very much. Sheikh Israt, thank you. Kunal, thanks for Mangaldeep, sir. Thank you. So, what I can say that structured one will be, I will be able to fit it into the rows and columns. The kind of a data, right, which can be fitted into rows and columns, and mostly the structured one where we can store it in the kind of a normal database or RDBMS database, right? So which is coming from the spreadsheet, could be coming from the Excel sheet, or could be from any source, and which can be fitted in rows and columns. But when I'm trying to talk about unstructured one, which is mostly the text data, which is kind of a video, audio, right? Audio data, text data, video data, right? Images, we are trying to deal here. So now why deep learning came into picture, why it is become very famous? Let's try to understand the impact this technology is trying to create over here and the kind of a technology we are using, right? So now everything is getting digitalized, and most of the data which is occurring here, you won't imagine that 70% of the data, or less, not 70%, I would say 80% of the data which is created every day, right? So within every day, if you try to think about the volume of the data which is getting created, right, which is getting generated in the entire universe, will be somewhere in the zettabytes, right? So I would say somewhere around 7 to 10 zettabytes of the data is created every day in the universe, right? Zettabyte equal to, I would say, 10,000 GB. And when I'm trying to talk about 10,000 GB of the data is created every day in the entire world, and which is 80% of the data is unstructured data. And what is this unstructured data, how it is coming from? So you're trying to interact in the Facebook, you are trying to upload the images, you are trying to use Twitter, you are trying to use your digital right, clocks, you are trying to use the phones, right? So you are using X, Meta, whatever format you are using, or let it be a digital classes, let it be a WhatsApp. So all the social media communication channels everywhere, whatever the data is generated, either it is a text, it is image, or a video, right? So that makes this machine learning vulnerable, right? So because it is mostly trying to deal with the structured data, so that's make it vulnerable to handle this kind of a huge volume and kind of a structure of the data. And that's the reason deep learning came into the picture and become, nowadays it has become very popular, right? So everything is getting into something called as generative, right? Generative mode and generative AI. This is what we are trying to talk about. So we'll try to understand and we'll try to connect the journey from deep learning to generative AI in this series. And obviously, if you guys try to attend the last session, I will try to focus some of the key trends in generative AI in today's session, right? In today's market, and what are the SOTA algorithms and all. We'll try to talk about it whenever the time permits. So let's try to understand, guys. I think everyone is now comfortable and able to understand what is deep learning. And in the deep learning, guys, we have three kind of neural networks which we'll be using here, right? Neural networks in the deep learning. So what kind of a neural network we are using here? One is called as ANN, artificial neural network. Second is called as convolution neural network, and the third one is called as recurrent neural network. So don't worry, we'll try to discuss in detail, but today's the showstopper is ANN, artificial neural network, right? So we already seen convolution neural network. We try to touch upon the RNN also. in our previous session. Still, we'll try to take as a revision all these neural networks as well. I will try to consider a few of the things out here, and then we'll try to talk about the generative AI sessions in the last couple of days, right? So coming back to the thing where we're trying to compare the things with human brain and the artificial neural network. Since today's and couple of days, next 2 days, we're trying to focus this on the artificial neural network. We'll try to understand what is this artificial neural network is all about and how it is getting evolved, right? How exactly it's got evolved. So let's try to understand this one before we jump into ANN and try to understand the entire ANN, right? When we try to talk about artificial neural network are nothing but neural network, right? They are coming, or I will directly say that they are the exact copy of the neural networks which are present out here, right, in the human brains. So I will try to talk about Macaulay and Pitts. When they try to understand that, they want to create a copy of the functionality which is same as a human brain's functionality, right? Neural network. The way neural networks are working, they try to make an effort that if I can create a copy of this kind of a neural network, and obviously it will be a artificial copy. It is not a biological copy, since it will not be a flesh or kind of a neuron, kind of a cells, but we'll try to mathematically compare this one. We'll try to create a copy of this one, and we'll try to achieve something called as artificial neural network, which can be given to the machines, and machine can exactly perform the task the way human beings are trying to perform. Okay, so that was the objective when we try to come up with this one method in artificial neural that teaches computer to process data is way inspired. Yeah, awesome. That's what the Ishwan Kumar sir, that's what the correct understanding is all about. So all these things started with they are trying to achieve the copy of the human being, right? Correct, sir. Yashwan sir, your understanding is correct. That is the correct answer. So all these things started with they're trying to make an efforts to copy this functionality, and that's how they ended up with the artificial neural network, right? So now we are clear. Artificial neural networks are nothing but the copy of the biological human neural networks, right? So then let's try to understand. Whenever try to talk about the artificial neural network, you can see this kind of a circle diagram, right? So always whenever when people try to talk about this artificial neural network, they'll be talking about this kind of a diagram first, right? So what is this diagram? This is nothing but called as perceptron. It's a multi-layer. I would say, to be precise, it is a multi-layered. Okay, it is a multi-layer perceptron. I would say multi-layer. We'll go over on it. Like we'll try to understand what is multi-layer perceptron. But in general, we'll call this architecture as a multi-layer perceptron, where the first layer, which you can see here, it is called as input layer. The in between layer will be called as a hidden layer, and there will be an output layer where we'll be able to get output. So what will happen is we'll try to pass a data out here as an input, then it will be processed out here in the hidden layer, and we'll get our predictions or output y hat out here. So this is the connection or layer which they created, which they called as a multi-layer perceptron. And the gentleman Macaulay and Pitts, they created somewhere around 1942 or 45. They created the first such efforts, and that efforts was called as single neuron model. Okay, single neuron or single perceptron model. Single perceptron model. And what they did is, like, we'll try to discuss this detail. They were able to create only single neuron. So since this neuron is when we try to talk about the neuron, it is a biological cell. So when we try to create it artificially, we'll call this as a perceptron. So that's the only difference out here, perceptron. Okay, we'll try to call this as a perceptron. Perceptron means it is a copy. It's an artificial copy of the neurons. Neuron are nothing but this kind of a circle, right? Granule level, the smallest, minute part of this human brain functionality is called as this kind of a circle, is called as neurons, right? And there is a complete wave, or we can say network of the neurons, thousands and billions of neurons which will be present over the entire body, and they will be making this functionality happen the way human beings are processing, right? The way they are trying to do the cognitive effort, they're trying to analyze the situation, able to take the decision and the perform the actions, right? So that's how the short brief history will try to go around it. Let's go back to our biology class for a while and then try to understand, and we'll try to compare both this diagram, right? How the exact copy has been created and what was the motivation around it, right? So let's try to understand first that when I'm trying to talk about the human brain, this is the diagram. We'll try to talk about the upper diagram, and we'll try to in a very, very brief manner. I don't want to become a biology expert out here, but in a brief manner, which we hated, I am sure that in our biology classes, everyone hated these classes to understand, but still, now we can understand that this is very crucial to understand the neural networks. So we'll try to focus for next 10 minutes, try to understand how the human brain exactly works, right? So that is what we're going to find out here. And then we'll try to talk about the artificial neural network, how they created this copy. So let me rub the things and try to understand. We'll try to focus on this diagram first. All right. And then we can talk about how they created this copy, right? So let's try to understand how the human brain functionality works. Everyone knows that what happens is we receive something called as signals. Signals are received by the human brains, and we try to process that signals. And then basis of the processing, whether the signals are strong one or crucial one or important one, we'll try to emit that. We'll try to emit that signals so that there is a respective action can be taken place, right? Respective action can be taken place. This is what exactly happens. Don't worry, we'll try to understand. There is something called as dendroid here. There are three parts actually, three parts in the human brain which perform the entire communication and the human brain processing system, right? So entire communication system in the human brain works in the three parts. First part will be called as dendroids. All right. So DENDRITS, dendroids, right? Hope you are able to see this one. If you want to see the correct spelling, this one is the dendroid. So this dendroid is nothing but this kind of a threads. Okay. So these threads which I am trying to showcase here, these are called as dendroids, which act as an input system, right? So the second thing which is called as the cell body out here, right? Second thing is called as cell body. This is the minute single part of the body, and this is how we can call this as a neurons, right? Neurons. And within the cell body, you already know that there is a core, there is a membrane, and nucleus is there. There is atom, proton, electron. If you have learned the science class, you already know what I'm trying to talk about. There will be protons, electrons, neutrons, right? So these are the minute parts which will be revolving around our core like this one. And this is what are responsible for performing all this processing of the information. We'll not go into that detail. I don't want to make you bore, but try to understand that when I'm trying to talk about this circle is something called as cell, right? This is the minute part, and within that we'll have a electron, proton, and so on, like dots, which will be revolving and which will be able to make the things happen, right? So when I'm trying to talk about, let me rub the things once again and let it write it in a better manner. So when I'm trying to talk about the human way communication, this consists of the three parts. First part will be called as dendroids, right? Dendroids. Then second part will be our cell body, right? And the third part will be called as axons. Okay. Third part will be called as axons. Now, what exactly work they are trying to do? So dendroids, I will try to showcase this kind of a threads or kind of a lines we are able to see. This is called as dendroids. So where we'll be passing all the inputs information out here, right? We are passing the input information. Then once the input information is passed, it will be received in the cell body, which will try to process the information in processing part. So it will try to process, and then when the processing happens, whatever the signals, I'm trying to talk about signal means this is something called as info, or you can say this is the information which is coming out, or which is called as input, which is coming out here, right? So once the input is received through the dendroid, which is get processed in the cell body, and based on the criticality of the signals or information, or based on the importance, so they will try to take the decision whether this cell body will get activated or not activated. Activated means if you want to, they want to process this information, they want to pass this information to the next cell, next neuron, because we are just talking about one part. There will be several other parts, and there will be such layers, and then it will be going toward the several body parts, right? Several body parts, and that's how the action happens, right? That's how the action mechanism happens in the human brain. So once I am able to receive this input, and then it is getting passed here, and based on the criticality or the importance of the information, they will decide whether to activate, right? Whether to activate this neuron or not to activate. Activate means you guys might have seen when we try to showcase the pictures of the human brain, right? So they try to showcase that some of the neurons are activated, like they are glowing, right? There is a spark of electricity. So they are glowing means there will be a spark of electricity which is happening out here. That means that neuron is getting activated. Electricity spark means they are glowing literally. You can see some kind of electricity is blown here, and they are lightning. There is a lightning happening, means whatever information has been received by the dendroid and has been processed in the cell body, which is important, and then it has to be carried out to a proper actions. for the proper action, and the carrying work, which again you can see these kind of threads are here. So that carrying works are done by the axons. So these axons carry out these signals and try to reach them, make them fetch towards the respective body parts. Axon terminals are also called as synapse. Yeah, correct, Sai. So your correct understanding is correct. So they are called as synapse, but we'll not go into details. So what we want to understand is how the human functionality works, human brain works, right? So now let's take the example, what is happening out here. So let's imagine now, if you are trying to see that the moment you are trying to go out, right? Let's imagine it's an ordinary day and you are trying to go out, right? Now it's a bit of summer, right? So when we go out in the afternoon, obviously you will start sweating, right? Because of this entire hot kind of environment we have. It's trying to reach around 35 to 40 degree, right? When in the afternoon, and the moment you try to go out and we are not wearing any kind of a let's say you are not wearing cap or hat, anything, and if you are going out, obviously your body will start sweating, right? You will start sweating at the time. So how these things is happening, how the sweats come around to keep your body cool, right? Everyone understand that. So at that time, what is happening, the moment you're trying to go toward this your sensory organs, right? So this time the sensory organ will be like your eyes, your skin and all, right? So the moment you are going out in the hot hot air or in the sun, right, in the mid or afternoon of the day, and then you are trying to feel the cold or warmth of the day, and then obviously at that time if you are not doing any proper protection or not using any kind of a you can say just to stay secure from this kind of ultraviolet rays or sun rays, so obviously you will get burned or something like that. So that the reason, that is a mechanism which is getting activated. So you are receiving inputs, it is trying to process that information, it is very important, and that's the reason that it is trying to take the action that your body will start sweating, right? Your body will start sweating, you will find yourself in sweats, right? So that's how the reason happens, right? So, or let's take the simple example, you're trying to see that you are trying to touch any hot object. The moment your finger try to touch any hot object, immediately that information will be processed through the brain and it will try to go through the axons, and the moment you try to touch the hot object, your hand will be pulled back, right? So how these things is happening, the same way, like the dendrites will carry out that sensors through the sensory organs, it will try to carry out the information, it will try to process, and based on that, that cell will get activated. Now what kind of a cell will activate it? If you're trying to touch the hot object, obviously the cells which are present, the neurons which are present in the body of the hand, right? So that is how it is getting activated and the action is happening in the human brain, right? So let it be logically reasoning, let it be any kind of action, this is same thing is happening. All right, so everyone understood how the brain happens. Now the same functionality is now copied, because they want to make the machine smart, right? They want to make the machines smart in order to perform the activity just like the human being, right? If you want to make the human being kind of activity, obviously you will have that kind of a mechanism, and that's the reason they came out with this artificial neural network, right? So now here the dendrites will be called as our input layer, right? Let me rub these things, and now we'll try to compare this one part with each other. Now when I'm trying to talk about the dendrite which are responsible to carry out the information as an input, we have this layer, right, which is called as input layer. So input layer is working as a dendrite. Then we have a hidden layer which are working as a cell bodies or kind of a cells which are trying to perform the information processing, performance of the processing part, right? And then as the axons are carry out the output, we have a output layer out here, right? So everyone clear now what is happening and how they copied the entire human brain activity. And when they tried to copy this at the first time, they were able to create only one single neuron. So this Macelo and Pitts, sorry for the spelling if I'm right to write, but I will cover that in upcoming slide. Macelo and the Pitts, there were the gentlemen, and around 19, let's say 45 or 50, they created the first concept, which is called as single neuron model or single perceptron model. They are proposed. At that time, what was happening, they were trying to pass the information and they were trying to activate or not to activate this information and just give the output. That's the only reason, and they realized that this kind of a mechanism will not work, and that's the reason that gave a birth to a first multi-layer perceptron model, where the several neurons or perceptrons are connected and stacked over each other, and they are connected by this kind of a layers, right? These layers are connected to each other, and that's how the mechanism is able to produce the output. this mechanism is able to produce the output. So that's the first thing and first history when this all these things came into picture, which is inspired completely from the human brain or human kind of a neural network system, and they try to make a artificial copy it, right? So this is what the deep learning talks about. This is one of the algorithm, artificial neural network. So when I'm trying to create this artificial neural network, let's imagine this is what we have seen now. So this kind of a diagram or architecture which we are trying to talk about, that there will be one input layer which will be get into the hidden layer, and it will be able to create a output out of it. This will be our input, this will be our hidden layer, and this will be our output layer. So when, okay, let me give you a brief overview. So this is something called as they created artificial neural network. When to the artificial neural network, which is try to mostly work on the structured data, right? Structured data. When I'm trying to talk about the image data and video data, you know guys that along with the ANN, I'm trying to create this kind of a block, some additional architecture, which block consists of the convolution block, right? Convolution block, which will be able to extract the features from the images, and I will try to join this with the ANN, and that is called as CNN architecture. Because that time the data is changing, we are trying to use unstructured image, video, audio data. At that time, I need to understand the features. That feature will become my input to the artificial neural network, and it will be able to give you the output, right? And then when I'm trying to talk about the sequential data in the sense which is mostly related to the human language text data or kind of a time series related data, I realize that I will need a one more mechanism which can understand this thoroughly, which can understand the human language, natural language, which is called as, and then it will be able to give me the output. That's the reason they gave a birth to a neural network which is called as a recurrent neural network, where it can accommodate the lot of inputs at the same time. Because if you try to see here, if I want to pass, right, if I want to pass the 10,000 words, what I will have to do, one neuron will be able to take one input, right? So in that case, how many neurons I will have to create, guys? If I want to create this kind of architecture, let's understand quickly from the audience side. So awesome, Sahil, correct? So if I want to create a neural network which can accommodate 10,000 inputs, obviously I will have to create a this big, yeah, Siddharth sir, Sahil, correct sir. So I will have to create a huge neural network, right? Huge neural network which will have like this kind of a starting from 1 to 10k neurons, right? 10k neurons. That's the reason. And again, try to understand when I'm trying to create this big neuron or this kind of a big neural network, at that time the kind of a calculations, try to understand from the point of view, from the calculation point of view. So how much cost I will incur, how much cost, how much energy, and how much processing power I will require in order to process 10,000 neurons, right? 10,000 neurons. So you will understand what I'm trying to talk about. This complexity of the calculation, we'll try to go into the detail, and we'll try to understand about the back propagation and the gradient descent algorithm, which is trying to take the derivative, right, with respect to the derivative of loss function with respect to weights and derivative of loss function with respect to bias. This kind of a derivative calculation which are happening in the background, which is able to receive you the output, right? At that time, 10,000 neurons, when I'm trying to take the 10,000 derivatives, which will be complicated, right? So that's the reason they gave a birth something called as, if I want to accommodate this kind of a thing, they gave a birth to recurrent neural network, which can have a similar structure like this one, where we're trying to pass these inputs, and then it will have this stack layer, and then they will be able to give that output again back to the neurons. This architecture, which if we try to expand this, which I will try to showcase also in upcoming days, so which will be looking like this one, unrolling this one will look like this one, and it will be able to take accommodate x1, x2, x3, x4 up to xn at the same times, right? So I don't have to create this kind of a complex neural network architecture, right? So this kind of a this is just the small overview, guys, which I'm trying to talk about, but sure we'll try to talk about it. So this will be able to accommodate simultaneously the multiple inputs. That's the reason, that's the beauty of the recurrent neural network. And these people, they went ahead when we try to talk about the complex natural language processing and natural human generation, human like understanding for the machines, they were able to give a birth to the complex model like LSTM model, then the BERT model, right? So these are the nothing but they are coming from the recurrent neural network, and then the GPT kind of a model, which everyone now is fascinated about, right? Chat GPT kind of model. All these roots lies into the recurrent neural network, correct? So I hope everyone able to understand now and able to collect. how the artificial neural network works upon, what is the inspiration, and how they can be compared with the human brain, right? They are the exact copy. And when we try to talk about the different tasks, they gave to birth to the different kind of a neural network based on the benefits and the advantage we are trying to understand. Correct? Awesome. So guys, just give me quick confirmation that we are on the same page. You are able to understand this, and you are able to understand why there exists this different kind of a artificial neural network. Then there lies a different architecture, which is CNN, and then there lies a RNN, and how the RNN works upon, right? Okay, awesome, guys. So couple of more confirmation or any questions quickly, so we can move ahead, guys. Awesome. Thank you, everyone. Sahil, Vidya, Bhakti, thank you, guys. So let's try to move ahead. Hope most of you already might be knowing this thing, but it will be a good revision to understand. Yeah, guys, we'll try to cover CNN, RNN also in upcoming lectures, and we'll try to, if possible, Surya, thank you, Vidya ma'am, thank you, Shweta ma'am, thank you, everyone. So if possible, we'll try to cover also generative AI, GPT kind of architecture. I will try to give you an overview how the machine level translation happens, okay? Last day, I'm going to make it very exciting, guys. So we'll try to understand, okay, how the transformer architecture works upon when we try to talk about the machine level translation. Machine level translation means when we are trying to translate from one language, let's imagine from English to German. If I want to translate, how that entire translation happens, I'll try to make it work for you by hand, right? We'll try to make this exercise by hand. We'll try to understand how this translation happen exactly, that what we're going to focus, and that kind of understanding we'll try to build out here, right? How this transformer understand. And once you understand the transformer, guys, then GPT will not be a big deal for you. You can create this kind of a GPT kind of architecture or chat GPT kind of a application, okay? So that's what we are trying to aim at here. So we want to build our understanding in such a way that we'll be able to understand this kind of architecture as well. All right, guys, so let's move ahead then without wasting much of the time. So let's make a use of it, and let's try to move to next. Awesome, guys, thanks for your response. You guys are really amazing. So guys, let's quickly have CNN. I'm going to cover, Siddharth sir. I'm going to cover in detail CNN in upcoming lecture, how the CNN works. I'll try to talk about RNN, and the last day we'll try to talk about the GPT architecture. Maybe I'll try to showcase you the machine translation. Don't worry, we'll try to cover in detail. So guys, just before we go into detail, the working of the artificial neural network. So awesome. Thank you, sir. So let's try to understand, if you want to achieve, you want to become an AI engineer or expert in this domain, right? So now why I'm saying AI, because I'm not talking about machine learning, because machine learning, we are using some kind of a statistical algorithm, right? So when I'm trying to talk about the machine learning, we are using this kind of y equal to mx plus c, and either we will be doing three kind of a task, right? One, either we are doing regression, right? Either we are doing regression, or we are doing classification task. I'm talking about task, right? So classification task, or I am doing third task, which is a major task, which is called as clustering, right? So this is what we are trying to achieve using the machine learning, where we are using statistical formula y equal to mx plus c and statistical algorithms, right? So but here, out here in the AI, we are not using machine learning, but we are trying to go advanced, and we're trying to use something called as ANN, CNN and RNN, right? ANN, CNN and RNN. So if you want to become a master, if you want to understand this entire domain, and you want to end up, awesome, slow formulas, correct? This is a straight line formula which I try to talk about, which is used by the regression algorithm, right? So in order to predict any number, regression means I'm trying to predict any number prediction, right? Let it be a stock forecasting. For example, if you want to do a stock forecasting, you want to predict the temperature, you want to predict the sales, right? Any kind of a number you want to predict, that is called as regression, correct? So this is called as regression task. When I'm trying to do a classification means I am trying to create a category, and within that category, I am trying to bifurcate my data. So could be a binary category, let's say cat and dog, right? Or could be a like diabetic, non-diabetic, or you trying to do that whether it is a fraud or not fraud, right? In terms of the things, right? So this is something called as classification task. And when trying to talk about the clustering, guys, if I have a huge data, I will try to bifurcate that data into different regions like this one, right? Out of my entire data, where I will have a similar data set with me, right? Similar data set, that is called as clustering, right? So this is what the understanding we everyone have, right? Awesome, guys. So still you will get, I think Chandana will share the attendance link. If not, it will be shared within couple of minutes, 15 minutes, after 15 minutes. Every day by 4:30, guys, you will get a link to register yourself, right, for the attendance. If I'm correct, Chandana, I think, then you guys will get the link and you can mark your attendance, guys. So guys, this is what we're trying to perform here, right? I will have a similar kind of a data in the clustering, right? So these circles will be in one session, triangles will be here, the plus signs will be here, right? So this is what we're trying to do. But when I'm trying to talk about the unstructured data, this is what we spoke about. We try to talk about the images, video, audio generation, right? So we are talking about the entire AI roadmap, right? So where you can end up with the open AI, like generative AI kind of a technology, right? This is what end-to-end things we are trying to talk about. Yes, yeah, guys. We'll try to share this PPT as well. Don't worry, we'll upload it to the LMS so everyone can refer. So, guys, when we try to go to this kind of an entire architecture, or we want to learn this path, which is also called as deep learning path, we try to start with the artificial neural network. Okay, so which is nothing but our ANNs, which we going to cover. Then we'll be trying to cover. Yeah, guys, don't worry. Everyone, I will be sharing these PPTs here in the LMS. You can refer to that. You can utilize this one, right? So guys, everything start with the Python and the statistics. You should have a good understanding. Not Python. Why Python? Because Python has all the application and kind of a support for upcoming machine learning, deep learning, generative AI technology. That's the reason we are trying to choose the Python programming language, because it is also trying to give you different packages and the features in order to accommodate this functionality. And then stats is obviously everything lies on the statistical concept as well. So probability and all, so that you should be able to understand what we try to talk about. And once you are able to understand this one, you have a good hands-on on Python and stats, guys, you can start understanding this kind of a neural network. So first neural network which we can talk about is artificial neural network, so which we're going to talk about, which will be able to handle the structured data, right? Structured data which will be able to capable to handle the images as well. But when it comes to the huge data set, it will try to fail. It will have some outcome. That's the reason we'll try to talk about the convolution neural network, CNNs here. So which can handle the object detection, which you already know that if I want to detect the face, I want to capture the action, I want to capture the car movements, self-driving cars, or any kind of a detection model. So which we talked about YOLO, which we try to talk about. And this kind of activity, image tracking, image recognition, image movements, or this kind of a segmentation movements, all these things comes into convolution neural network, this kind of a task, right? All computer vision related tasks which comes into the convolution neural network. Computer vision, like I found kind of a eyesight for the machines, right, which they can recognize everything by using this eyesight. And then when we try to talk about the third pillar, which is called as recurrent neural network, guys, and obviously in convolution neural network, once you understand, guys, there are the various architecture like VGG16, AlexNet, right, YOLO, SSDRN. These are nothing but these are pre-trained architectures, pre-trained models, which comes as a part of the transfer learning. Transfer learning means you don't have to create from the scratch all the architecture model. So they have already trained this model. You can utilize this model as a pre-trained model or transfer learning model, where you can customize this for your own data and you can use it as an application for your purpose, right? So that is a short concept. We'll try to talk about it, but I just to give you a hint. So this kind of a models are available which can be made a use for the image recognition, object detection, object capturing, live understanding of the things. And then we try to understand this entire pillar talks of the computer vision part, computer vision, okay, computer vision, CV. So this is what we talk about. This is what we talk about ANN. This we should understand. And then we try to come to this third pillar, which is very, very popular pillar, guys. Very, very popular thing. Very important if you want to become a Gen AI guy, Gen AI, right? So Gen AI entire understanding or become an expert for the generative AI, start with this pillar only. So, but prior to that, you should obviously have this understanding of the CNN and ANN. So you should start with this pillar, specially try to focus here, because in this pillar, guys, we'll try to talk about how to handle the human languages, how the human languages are handled, right, by the machines, by the bots, by the everything, and how the interpretation happens, how the text analytics happen. All these things will come into the RNN. And in RNN, we have a different architecture, then LSTM, GRU model, then BERT model, then transformer model, Then comes the GPT models, which are used as a OpenAI's model, GPT-1, GPT-3, GPT-4, right? So then, or let it be a now Gamma model, let it be a Gemini model, let it be a Llama model, which are whatever models are there, they are a base which are coming from this pillar, right? So in order to reach there, you should understand this entire recurrent neural networks, right? How the recurrent neural network works upon, how the entire understanding is all there, and what are the different architecture which are available. These are nothing but the architectures or models, you can simply say. The models which are a different number of layers which are used. So when I'm trying to talk about the models, they are using different layers of the RNN. So maybe they are using 10 layers, 12 layers, 30 layers, but in different way, they're trying to stack above each other, right? So that's the reason. Even when we try to talk about this kind of a models, right, out here, they are nothing but the convolution neural network only, but they are trying to use, maybe someone is using 10 layers, someone using 50 layer. When you try to talk about this RCNN, right? RCNN, this kind of a neural network, they are using up to 150 layers also, up to 150, up to 200 layers, 250 RCNN is also there, right? So RCNN or this kind of a model which are there, so they are using these are using this kind of a number of layers which are arranged in a proper manner to achieve the objective, right? So this is nothing but, this model are nothing but the base architecture used in a multiple layers, multiple architecture, they are stacked above each other, and that's how they become complex and useful for the next task, right? I hope everyone understood what is the entire thing, and some of the frameworks I have written here. Let it be Spacey, let it be NLTK, K-Train. This is obviously the Hugging Face, right? So we'll try to understand what is this Hugging Face, if time the permits, when we try to talk about Hugging Face is, guys, hub. Okay, this is hub, nothing but kind of a portal. They are trying to maintain all the models. They're trying to maintain all the models. You can use that model, you can train the model, you can connect to those models. This is nothing but a hub, this Hugging Face, right? This picture, it's a Hugging Face. It's kind of a portal. It's a kind of a, let's say, Play Store. So where they're making you available all the kind of a models, and we can train that model, you can use that model, you can download from there, you can connect to that model, right? So that kind of a Play Store, you can say, that is Hugging Face. Okay, K-Train is their methodology to train the different algorithm, right? At that moment, let it be an OpenAI model, so they're having the capability. So that is nothing but called as a K-Train model. All right, so guys, any questions, any doubt here? So before we start understanding our neural networks, artificial neural networks, this is the ladder you should pass, and then only you will be able to get up to this OpenAI. Okay, so okay, I'm getting a couple of responses that okay, everyone is on same page and we can move it then. So let's go into detail. We already talked about what we're going to understand here. We're going to understand the different architecture of ANN, what is perceptron model, how the ANN works, forward propagation, back propagation, activation function, loss function, optimizers, obviously how to train these models with the gradient descent algorithm, and then we try to understand the some kind of a limitations which are exist here, and then we'll try to talk about the regularization techniques which are coming here to take care of this limitation, right? So this is all the agenda about the artificial neural network looks like. So let's move ahead and try to understand. Okay, so guys, when we already spoke about these things, Hugging Face have multiple APIs, right? Correct, guys. So Senthil, sir, yes, you are understanding, because Hugging Face has different APIs. You can simply, in order to understand in a simple way, you can imagine that as a Play Store, right? Google Play Store. We have Google Play Store where you can download any application, you can connect to any application, you can use that. Difference between generative and explaining. Yeah, guys. We'll try to talk about that in last week. I'll try to cover. Don't worry, Fatima, ma'am. Okay, awesome. So since you guys are very enthusiastic, I will try to cover that. What is the difference between explainable AI and generative AI? In fact, we'll try to understand that what is generative AI is different from the traditional AI. Okay, so that's also we'll try to understand what are their capabilities. So when we try to talk about the capabilities of the Gen AI, there are two capabilities, right? One is from the text side, language side. Okay, let me write it here. So you guys, I will add it to your excitement more. So you'll be a bit more excited. So there will be two sides, guys, when we try to talk about this. One will be the language side. Okay, language side, and one will be the vision side. So these vision models are also there. If you try to understand this Gen AI, so Gen AI try to talk about the language sides. Like in the language side, we have a model like GPT model, where you receive a text, and you give back the text, right? You give back the text. And when we try to talk about the vision model, you receive maybe a text, but your output will be a kind of an image, right? So now you guys learn this. Sorry, or some model is there, right? Sorry, I don't remember. The OpenAI just recently launched this model, right? Sorry model, which is trying to create a video, up to 15 to 20 minutes, right? I will give you exact name. this model name. Okay, they created this capability, launched this month only. This model is able to give you you just provide the text, it will be able to generate image, it will be able to generate the video, right? It can generate any kind of a motion movie also, game, and all these things. Okay, all these capabilities come into vision parts. So there are two parts exactly when we try to talk about the generative AI, right? Gen AI part. So we'll try to understand this, how they are different from each other, what are their base models. When we try to talk about this one, we are using transformer models. When we are trying to use this kind of a model, we are using GAN models or variational autoencoder model. That also will try to focus, guys. At least I will try to give you a brief hint and idea how these things happens. Okay, this will try to understand, and then obviously explainable AI, how it is different, right? Oh, don't worry, we'll try to cover this one. I guess you guys are already much aware and deep into the techniques, so which will make my job very easy to take you guys to this far depth of the technology. Awesome. So let's try to understand formally. When we try to talk about the artificial neural network, this is the diagram which we can see, and which has the three parts, right? We talked about the dendroids, we talked about the cell body, and this is dendroids, right? This is the cell body, and this is the axons. So likewise, we have an input layer which is trying to pass our information like x1, x2, x3, x4, x5, right? So this is what is going inside here in this. Then this hidden layer, they're trying to process. In hidden layer, guys, there are two-step process happens. Two steps process, okay? There are two steps which are happening. We'll try to talk about, we'll try to bifurcate this hidden layer, and we'll try to understand what is going on in the background, how it is able to give a output. And then there will be something called as in the last layer, output layer, which is give you a prediction, right? So this is what the architecture look like. This is a multi-layer perceptron architecture or architecture of the artificial neural network, right? In general. So you cannot process this on the CPUs. You require a special computing unit, which is called as GPU, graphical processing unit, or could be a TPU, a tensor processing unit. We'll try to talk about why it is cannot be processed by CPU, because of the huge quantity of the data, because of the image kind of a data, right? So because of the video kind of a data, because of the audio kind of a data, which is getting converted into numbers as well. Let it be a single matrix or kind of a multiple matrices here, which is getting converted. So we require special computation power. So that's the reason this ANN or CNN or RNN cannot be processed on the CPUs. They can be generated or created, trained on the special computing units, which is called as GPU and TPUs. Okay, TPU is nothing but tensor processing unit. And tensor is nothing but a multi-dimensional array. A multi-dimensional, I will write in shortcut, dimensional array. A multi-dimensional array is called as tensor, so that they are able to accommodate that information into the tensors, and that tensor processing unit is available, TPU and GPU, and they can handle this kind of a processing in detail, right? So that's the hardware, special hardware requirement we require. So we cannot perform this here, right? So let's go back and try to understand quickly. So what is happening? And guys, before we try to understand and go into details, right? So let's try to understand, like I told you exact, right? So these are the gentlemen where we talked about Makello and Pitts. Okay, Makello and Pitts. Yeah, guys, my colleague will share a feedback link with you, okay, in a couple of minutes. And the attendance link, it is both same. So it will share. So maybe guys, Amar, Chandana, you guys can share the link simultaneously, okay? So guys, how this happens, let's try to understand the history which we already talked about, and I will give you briefly within 2 minutes explanation that what they try to achieve at the first model. That this is the first ever model which was created for the artificial neural network, and this model was called as single neuron model. Okay, neuron model or single neuron model, and this was created, you won't imagine, this was created back in 1943 only. So try to understand when these things entirely started in the back in the history, and these were the statisticians. Okay, these were the statisticians. Yeah, guys, so my colleague Amar has shared the attendance link. You can refer to it, okay, and mark your attendance. Don't forget to mark your attendance, guys. So back in 1943, these two gentlemen, okay, what they decided is, can we create a kind of a mathematical neuron model, which is a copy of the human brain functionality, okay, human brain neural network. So that's the reason they created, and what they created, they were able to create this kind of a single neuron at that time in 1943. Now single neuron, what happens is, what will happen, I will try to explain what exactly they try to achieve here. So we already know that everything works in this way, right? So we pass the information which is called as signals, right? So which were called as signals. So signal is nothing but an information. So signals goes inside it, that get processed right here in the nucleus. It get processed, and based on the criticality, based on the importance, whether the signal will be fired or not fired, right? The signal will be fired or not fired. This is what exactly is happening right in the human brain. And they try to create a copy of this model which was doing the same job, right? So this was trying to take this. You can understand this x1, x2, x3, nothing but they're trying to pass this information, right? x1, x2, x1, x3 up to n. They're trying to pass this information, guys, and then they're trying to process here. Now the next thing comes in, when I want to fire this information, means I want to take that information, pass it to the for the performing any kind of a particular action, right? At that time I am receiving multiple information. So how can I bifurcate which one is important, which one is not important, based on the weightages? You can see there they're trying to attain, or they're trying to apply some kind of a weightages out here. Weightage is nothing but small constant number. So kind of a 0.4, 0.3, 1.1, 1.2, any kind of a constant number you are trying to achieve or try to multiply to your inputs, right? In order to make sure that you're trying to give us some kind of a importance to the different inputs, right? So this is what is happening. So they created these random weightages, and they're random. They took it random, right? So initially they try to take this and multiply. Let's imagine this is 0.5. This input is multiplied by 0.5. This input, let's imagine, multiplied by 0.10. This input multiplied by 0.7. So where I'm trying to multiply this is what the summation happens inside that. And based on this summation, guys, whatever the, now which one signal will be strong, obviously the where I'm trying to process more weightages, right? So here the weightages will be to x2, right? This is very important. So what is happening is they're trying to take and multiply by the inputs and then trying to sum it up. And after summation, there is something called as activation function, which we'll try to understand in detail. So this activation function is responsible for firing the information, whether we want to fire or we don't want to fire, not to fire. And if the fired means that particular information will be passed on to the next layer and will try to achieve some kind of output. Otherwise there will be no output. And this is what exactly this model was doing. It was just trying to take the information, multiply by the weights, and they're trying to sum it up and then try to fire or not to fire. This was the only decision this model was taking at that time, right? So guys, colleague Amar has shared the link once again. You can please go ahead and mark your attendance. So you will not be, you will be able to give your feedback and attendance as well in the same link, guys. And please make sure that in order to get the certificate in the end of this series, so you are marking your attendance, okay? Guys, this was the neuron model which was created by McCallum Pitts, and they realized that this model, single neuron model, will not help us to perform or achieve the action or kind of a prediction which we trying to think or trying to solve any business cases, right, using this kind of a model. So that's the reason they realized, and then back in 1952 or 51, guys, they created something called as multi-layer perceptron, which we are able to understand this as a current neural network as of now, right? So this is what the multi-layer perceptron we talked about, right? This is multi-layer perceptron, which they're tied to stack multiple neurons like this one. They try to connect them to the next layer, and they created this kind of a layers: input layer, hidden layer, output layer, which this architecture becomes a multi-layer perceptron, and which will help able to solve the business use cases, right? Back in 1951, around it, they created this model, and that's how all the innovation started, right? Cool. So I guess everyone is now able to understand how the things happen. So let's try to focus when I'm trying to talk about this kind of a things. Let's try to focus what exactly happens, how the information processing happens inside this neural network. Okay. So we'll try to keep it simple as of now. We'll try to understand when I'm trying to pass the information, what exactly happens. And then maybe tomorrow onwards, we'll try to focus more on the activation functions, more on the cost functions, optimizers, what optimizer we should use, what kind of a cost function we should use, and how that combination happens. And end of it, we'll try to create our own architecture, right? Own model. We'll try to solve one business use case using it. So guys, if you want to understand what is happening, there are two concepts which is very, very popular out here when we try to understand this artificial neural network and their understanding and their working. So one is called as forward propagation, and second is called as backward propagation. Okay, second is called as backward. I'll write BK propagation, backward propagation. Okay, so these are the main two concept or the two process flows which happens. So I pass the information here, and then the forward propagation happens. And then once the information is processed, we get a kind of output, right? And if that output is not equal to the reality, whatever we are expecting, then the second steps happen, second process happens. So first process will be a forward propagation. Step 1 will be happening, where we're trying to pass the information and we try to achieve the output. And once the output is achieved, that output is not exactly to the reality, right? Not equal to actual thing, reality. So the second steps happen, second process called as backward propagation, which is going back towards this flow, right? So let me show you with a different color and make it a better understanding. So first time when I'm trying to pass the information, information will go to the input layer, correct? Then there will be hidden layer. This one is the hidden layer, and there will be output layer, right? So let's imagine I'm trying to pass one input x1, x2, x3, and then we try to multiply by weightages, and this is what the entire processing happens. And based on that, we try to achieve our prediction of y hat. If this y hat is not equal to actual reality, right, real number, whatever the real expectation we have, so we have a something called as loss, right? So when we occur the loss, the exact aim objective of this entire process is to make the loss 0, right? So make the actual and the prediction exactly equal, right? This is what we are trying to achieve. This is our objective. This entire process, when we try to pass the information, this passing to the hidden layer and then achieving through the output layer the prediction. So this process is called as forward propagation, right? So this process, and then when we see that after receive this forward propagation and no learning happens, guys, try to understand, the learning only happens in the backward propagation. So that's how the learning process happens in the neural network. So neural network, we are trying to simply perform some kind of a calculation and we're trying to achieve the output. This output is not equal to the reality or not equal, or whatever the loss is there, right? Since this is not equal to exactly, prediction is not equal to the reality, we have a loss, and that loss is not equal to 0. That's how the process happens. Let me show you to be the different color now. So the process happens where we try to go back in and we try to propagate back in the neural network, starting from the loss function to the prediction, from prediction to this entire weightages, from weightages to hidden layer, and hidden layer to coming back to the input layer, right? Backward journey. This backward journey is called as back propagation. So this kind of a two propagation happens, and this is how the entire architecture works, right? In back propagation, actual learning for the ANN or for the machines happens, right? So that is how that they try to learn the things, they try to adopt the things, and they will be able to give you the exact predictions or exact real-time process output, right? So this is what the, in short, you can say there are two process happens. One, we pass the information, it perform the calculation, give you output. If output is not equal, there stops the forward propagation. And the second process step starts where we go back through layer by layer, through weight by weight, through the cell by cell, and we try to achieve to the first layer itself. That is called as back propagation, where try to understand the learning of the machines, right? The learning happens. So I know it's a bit messy now. Let's try to understand. Okay. So guys, any doubts? What kind of a two process happens? Anything? Any questions as of now? So these are the two process happens, and based on these two process only, the entire machine learning, not machine learning, you can say the machines and the artificial neural network learns upon. Okay. Out of that, we going to understand our first forward propagation here. What happens in the forward propagation and how the architecture for the forward propagation look like. This is what we going to understand here. So end of it, you will be able to understand what exactly happens. People says that it is a kind of a black box, but it is not exactly. This is a mathematics which is in action in the background with the derivatives concept. Okay, stats and derivative concept. So as of now, let's try to understand what is forward propagation, what happens exactly here, and what kind of a process happens here, right? When we try to pass the information. Let's imagine, guys, let's take the simple example. You want to predict a BMI. So now BMI is a number, body mass index. It is a kind of a number. For usual person, the BMI lies between 25 to 35, right? So for normal person, BMI lies. What is the restriction on input variables of X1, X2, X3? So Murli sir, can you please tell me in detail, like what exactly restriction you are looking for means? So I'll be able to give the answer, because restriction will be there, like now up to you now. So what kind of a restriction you want to put it? Like we can usually pass all the information at a time, or you can pass it in the batches or anything. So if you try to tell me the some more details, I will be able to answer you. Okay, so guys, let's imagine the use case that I want to predict a BMI. So because BMI you want to predict, and then we'll try to understand how the forward propagation happens in terms of it, right? So in order to create a BMI, or in order to predict a BMI, guys, what information we require? Can anyone quickly tell me, guys? Awesome. Siddharth Gosar is already advanced. Weight, height. Okay. Or let's imagine I want to put one more information, height, weight, and let's imagine I want to put my height, I want to put my weight, and let's imagine I want to put my age as well. Okay, as age as well. Yeah, awesome. Height, weight, and age. Correct. Awesome, Shivani. Siddharth sir, thank you. So let's imagine these are the three inputs I require, and I can predict my BMI. And once I predict my BMI, if that BMI is between 0 to 25, I am a normal guy. So it is more than 25 and between, like, say 40. So I can say that maybe gender also. Yeah, but as of now we'll try to keep it correct. Gender also will play a role. So let's put gender also, X4. Okay, so W4, which is be coming here. Okay, so this is what you can say, gender also. So this information I can pass in here. Okay, and then once I receive the number, okay, this is my prediction number is BMI. This is what we're going to understand. So let's try to understand what will happen now. So what will happen? Height, I will call it as X1. So weight, I will call it as X2. Age, I will call it as X3, and gender, I will call it as X4 now. So the moment I pass here, okay, the moment I'm passing this information, so you can see this is called as input layer now, correct? So it is trying to take the information here. So when I'm trying to pass this information, you can see that this input layer and this is our hidden layer, guys. For simplicity, I have taken one neuron. In reality, there will be multiple neurons like this way, right? So there will be multiple neurons, and the layers will be also one, hidden layer 1, hidden layer 2 will be there. But for the simplicity and for the calculation, in order to accommodate here, I am taken single neuron as of here. Let's try to understand what exactly the process happens inside it. Okay, how we are trying to achieve the BMI number, predicting BMI number, given these inputs, height, weight, age, and gender. Okay, now what happens is there are two steps process happen. Before that, let's imagine this is hidden layer and this is my output layer. Now, if you see these thin lines where it is connected to each other, right? These thin lines are nothing called as weights. These are actually the weights which I'm trying to assign to my inputs, right? And based, there will be also one more weight. The moment I'm trying to pass this information and whatever the output coming out of this, that information output is also passed or multiplied by one more weightages, and then I receive my actual output here, okay, in the output layer, out of this output layer. So let's try to understand. Okay, let me rub this thing. Let me rub this thing and let's try to understand in detail what is going to happen. How can we take multiple neurons in hidden layer? Is there any point we need to follow? Yeah, sir. Obviously, nice question actually. Anand, yeah, sir. Bhanushri, sir. Correct. I will explain you, like, on basis of what logic we should take this. Bhanushri, sir. Okay. Yeah. And please explain our bias. Yeah, I will explain our bias also. Yeah. Okay, sir. Nice question, Bhanushri, sir. Nice question. So let's try. I will give you hint once we understand this process of the forward propagation, back propagation. I'll give you exact the hint, like the way how can we, when because we're going to create our own architecture here. At that time, I'll explain you like how many neurons you should take in the input layer, how many neurons we should take here in the hidden layer and the output layer. That explanation we'll try to understand. Okay, in detail. Now try to understand first. I'm trying to achieve a BMI here, BMI number prediction. This is what happening. And I told you this is exactly right. Let me write it in very quick manner. Age, okay, weight, height, and the gender. X4, okay. X4, and there will be weight W4, which is getting connected. Now, what is going to happen? The moment I'm passing this information, I told you these thin lines are nothing but the weightages, and these weightages are nothing but taken random at the first time. These are the random numbers which I'm trying to assign because I don't know the logic exactly. First time, even the machine don't know, right? The first time they want to predict, they don't know anything. They will learn in the backward propagation, but at the first time they are taking some random numbers and trying to multiply here. This is what going to happen at the first time, okay? So you should be able to, maybe sir, if you are not able to see the chat, maybe you can log in back. So you'll be able to see this chat, okay? So chat is same, sir. Kadali sir, Vijay Lakshmi ma'am, sir. So whatever now you tapped in, this is the chat window only. Shall we give 0 initially or random number? So Bhanushri sir, 0 we cannot give this because if we try to multiply by 0, what will happen is, so that entire input will get negated, right? So it will become null. So more than 0, but we'll try to restrict between like 1 maximum. So Bhanushri sir, you are saying 0, right? 0 or O. So we cannot keep, but what the range we can keep is, okay, thank you. So what we can keep is, we can keep a very less weightages up to 1. So initially we can take like say 0.2, 0.3 up to 1. Okay, this is what the range actually. Or people, they try to give very less weightages like this one also initially 0.001, 0.002, like this one also, because they don't want to complicate the things. Okay, so this is what will be giving the weightages. So what are the two steps process happens when the hidden layer information goes to in there, that will try to understand. Step 1 and step 2 happens. Okay, so there will be two-step process. So in step 1, what I'm going to do is simply there will be input which will get multiplied by the weightages. Okay, so this is the step 1 will happen. So x1 will get multiplied by w3, x2 get multiplied by w2, x1 get multiplied by w1, and we'll try to sum them. So this is what happens. So summation of input into the weights, this is what happens, and this weight will be random one which will be taken between the range of 0 to 1, between 0 to 1, right? So we try to assign the random weightages, then we'll try to multiply them and we try to sum them. This is what the step 1 happens, and plus there will be biases b, right? So this is also a random number between same range between 0 to 1. So this is what exactly the step 1 will happen. Once we are trying to pass in step 1, we try to take the input, multiply by the weightages, and once the weightages it is getting multiplied, we try to sum them, and whatever the summation happens, then now in step 2 there will be something called as activation function. Okay, so something called as activation function. So this activation function, now whatever the summation and multiplication we have done here, let's call this as y. That y will go through this step 2, this will go through the activation function. So that is called as step 2. You can see here, whatever the weights multiplied by the inputs, we have a sum dipped up. All this summation of this multiplication of input to the weight will be passed on through the activation function, and this activation function will try to do 3 jobs, guys, here. So what is the job this activation function will does is try to understand. But first thing, it is able to decide whether to fire, right? Same like the human signals, fire or not to fire, means whether to pass on the input, whatever the input received, whether to pass on to the next layer or not to pass. Okay, or simply you can say activate or not to activate. Okay, so let me rub these things and let me write it the functionality once again. So the 3 types of functionality will be able to pass. Yeah, correct, Sal, your understanding is correct. Okay, so that's correct. So let's try to understand here, guys. Let me change the color. So 3 functionality. One is fire the signal. That is what the activation function does, because in step 2, whatever this multiplication y we have done, that y we are passing through the activation function, right? So this activation of whatever we have done y. So this is the step 2 which happens. Okay. So in step 2 activation function, what activation function does is signaling. So whether to fire the signal, means whether to activate that neuron, activate or deactivate. That is the first thing we decide. Okay, so whether this, whatever this neuron is there, right, there will be multiple neurons, so the same information will be passed on to the second neuron, third neuron, fourth neuron, so on. So whether to activate or not to activate, that is the first functionality we'll try to do here. Okay, so activate or not to activate that input. So once it is activated, then only it will be passed on to the next layer, right? So that is the first functionality which activation function does. Then something called as making a regularization here. What is regularization? Means scaling. So it will try to bring that whatever the input into multiplication of this weightage is there, that they will try to perform a transformation between 0 to 1 or between -1 to 1. Okay, -1 to 1, 0 to 1, or it could be between minus infinity. Okay, not minus infinity, we can say between 0 to plus infinity. Okay, this kind of a transformation thing is done. So that is the second functionality. Based on the different activation function, whatever the input we have taken, it will try to transform that. Okay, transform that between the ranges. What ranges? 0 to 1, -1 to 1, or 0 to plus infinity, up to any number. Okay, so this is what the functionality does. And the third functionality which will be taken care is bringing the non-linearity. So what is non-linearity? In short terms, we'll try to understand. Non-linearity means if I try to plot my data, okay, this is my data. If data is now plotted, when I'm trying to take the data and try to plot it, if it is trying to create this kind of a distribution, this is how my data look like, where I can fit it to the normal line. Like I can create a straight line and I can fit to this. This is called as linear data. But sometimes the data will not be linear, right? So my data, when I'm trying to create my data or plot my data, right, on the scales, my data can look like this way also, right? This kind of a data I can have also my pattern of the data I'm talking about. Okay, so on my pattern of the data, we cannot be fitted to the straight line, right? Cannot be always fitted to the straight line. So this is called as non-linearity, right? So my data is non-linear. So that non-linearity, bringing the non-linearity to my data or activation function, also a job of an activation function, right? So these are my three basic jobs which this activation function does, right? So what are my three jobs, guys? In order to revise this one, so the step one happening here, in step one, I'm trying to take the input capital X multiplied by the weightages. I'm trying to sum them. And once I'm trying to sum them, I'm calling this as Y. That Y in step two, okay, which is in step two, I'm passing it to the activation function, activation of Y. And this activation does the three job. One is transformation of the data into the different scale. One is whether to activate, means whether I should send this information further or not should send this information further. That is the first job. Second job will be activation or not to activate, okay, based on the criticality, based on the functionality, right? Because every neuron's information cannot be passed on, right, if it is not critical. So the same like the human brain functionality. Then the scaling of the data, correct? So we need, why we need scaling also, this is very good question, because sometimes there will be some outlier, some data will be on bigger scales. So when we try to perform the calculation, guys, so if you have a bigger numbers, the calculation will be very high. That's the reason they're trying to perform the transformation or scaling of the data between -0 to 1, -1 to 1, or could be from 0 to plus infinity. So these three kind of a scales, they will try to transform your data, right? Because your data could be in the scale of the 10,000s, could be lakhs, could be millions. So all this data, if you try to take as it is, there will be multiple calculations which can be happening. So which is not affordable, because of this calculation power, we try to perform this scaling, right? That's the reason scaling. I'm bringing the non-linearity. Non-linearity because not every data will be in a linear format. So we have to handle all the kind of a format or presentation of the data. So that is the three reason we have this activation function out here. So there are around 25 to 30 activation function which are available. Let me write it here. 25 to 35 plus activation functions are there. Do we need to learn all of them? Not required. We'll try to cover the popular 10 activation function, which is more than enough for the start. And then you can keep on building your knowledge, right? So in order to understand in the forward propagation, guys, let me revise again what is happening. Step one happening. In step one, I'm trying to take the weightages, multiply by the inputs and try to sum them. That is called as Y. And that Y in step two is passed, right? So this is step one here and step two, and after that only we are getting something called as our output, right? Our output O, we can say, out of this hidden layer. And in step two, I am whatever the multiplication and summation I have done here, product of this along with the biases as well, this all the things will go into activation function. And then whatever the output, let's imagine O1, we are getting that O1 will get again multiplied by W4, one kind of a new weight, because there is a connection between the hidden layer and the output layer. And then we'll get our something called as Z1 here. So Z1 will be Z or O multiplied by W4. And that again, there will be one more activation function in the output layer, right? So there will be one more activation function where activation function will be passed on to this Z1. And then in final stage, we'll receive our prediction Y hat, right? So this is what the steps happen. And this is what the hidden layer happens, guys. All right. So hope everyone understood what is this. And this entire process is called as forward propagation. Forward propagation, and through which we try to receive our output Y hat. Now what happens? Okay. Whether this process will stop? No, this is only half thing done, right? So this is half of the iteration. Now once forward propagation happens, so this kind of a step one, step two happens, right? So there will be activation function which will be lying at the two steps, right? One activation function lying in the hidden layer and one activation function is lying in the output layer. So whatever the output is coming here, let's imagine we call this as Z. So this Z will get multiplied by W4, that will become Z1, and that Z1 is also going for the activation function, and end of it, we're going to receive our Y hat. Okay. Yeah, guys, my colleague Amar will share the attendance link once again. Okay, Hriday Kumar sir. So Y hat, and once we receive this Y hat, guys, what is the next step now? So I will try to compare, I will try to create a loss function or try to compare whether whatever the prediction I have received, whether it is matching with my reality Y, right? So if it is not matching, then I have something called as loss. Loss is actual minus predicted. If loss is not equal to 0, that's how my backward journey starts, my backward propagation, sir. No, guys, the sorting the data gets stored in all the... No, guys, it is not going to store the information. Okay, let's try to understand. It will not store. It will try to perform the let's say whatever the process I explained you, step 1, step 2, that processing part will happen. Data will not get stored, okay, at that time. So that's how we'll have a multiple iteration. That's the reason we have a something called as multiple iterations, right? So this happens multiple times. Like when we try to train our model, we will take something around 1000 iterations. 1000 iterations means 1000 times this process will happen, right? So that's the reason. I hope everyone understood now. So then the loss process will try to take the loss. Loss is for calculating one instance, guys, only. So let's imagine out of end of this, what we're trying to predict here. We're trying to predict the BMI. Now this predicted my BMI as 25. Let's imagine. Okay. So my actual BMI is not 25, 30. So there is a loss. It is not matching to my reality, right? So there is a loss of 5. So this 5 now, my model, my entire algorithm. So now this will try to make this 5 equal to 0. Okay. So this y hat loss, they will try to make this loss as close to the 0. And that's how my reality and the prediction will match, right? And that's how I will trying to go back now. They will try to understand now. So in the backward journey, they will try to update these weightages. Okay. So whatever initially I took the weightages, this were not correct. So that means whatever weightages I have taken is not correct, because in order to predict, and let me write the equation, right? So why is we trying to predict BMI? So the equation will be WX plus B, right? So by using this formula, they are trying to predict the BMI. Y is my BMI, X is my input. So input could be age, multiple inputs will be the height, weight, and the gender, and this B is a bias here, right? So basis of that, I'm trying to predict my BMI. Now, whatever, now what is known to me, X is known to me, Y, W and B was unknown. So whatever value of W and B I have taken initially, these were not correct. So that's what proves, because I predicted 25, my actual value is 30. So then what I need to do is I need to do a back propagation. Back propagation means whatever the model parameters are there. What are my model? Y equal to WX plus B. This is my model. And within the model parameter, W and B, R values are not correct. Whatever value I initially taken random are not correct. I need to revise, or I need to find out these values of W and B. If I found out exact value of W and B, so I can easily find out my prediction Y. So that is what the entire concept lies upon. All right. So hope you guys enjoyed this entire forward propagation. And what is forward propagation? What exactly happens? What is model equation? What we trying to achieve? In back propagation, simply we're trying to find out the exact value of W and B. If we know the exact value, we can easily predict, because X is given to me. So we can perform the exact prediction where my loss will equal to 0. All right, guys. So hope you enjoyed today's session. You were able to understand what is forward propagation, what happens, what is artificial neural network, and how it is compared with the human brain, right? How they try to create a copy, what is the evolution, how the thing started. Any questions, any doubt, guys, quickly, before we try to end up our session? And tomorrow we'll try to understand the back propagation, activation function, optimizer, all of the things. Okay. Once again, Amar has shared the link with you guys. So please try to mark the attendance. Okay. Sahil, content was incredible intent. Okay, Sahil, thanks for your kind words. I really appreciate. Okay, thank you, sir. Kirti Kumar, sir. Thank you, ma'am, sir. Yeah, guys, I will suggest the readings as well. Don't worry for you guys. So, guys, any questions? Yeah, attendance link is already shared, guys. Yeah, awesome, sir. Your understanding is correct, Siddharth Ghosh, sir. So our main iteration or main objective is to make the loss function 0 through making this process happen multiple times. Okay. Yeah, guys, Amar will share the attendance link once again. Okay. Vidya Ugare, ma'am, thank you. Yeah, ma'am. First, it looked complex, but we'll try to make it very simple. Okay. We'll try to make you understand. Guys, Amar has shared the attendance link once again. Hope you enjoyed this session. You can share your thoughts as well. Hope you are able to understand, enjoy what is happening. If you have doubts, again, we'll try to take it again forward. Thank you, sir. Bhanushri, sir, thank you. Thanks for your kind words. I really appreciate. Guys, your engagement is really amazing. I really thank you, everyone. Okay, thank you, ma'am. So it's a bit difficult for me to understand from the memes. Sorry for that. So Bhanushri, ma'am, thank you. Fateh Kunwar, thank you, ma'am, sir. So thank you very much. So guys, we can continue our journey tomorrow as well. Yeah, thank you, sir. Thank you. Thank you very much. So guys, please forgive me if I am confused with your genders, because reading at the name, it is sometimes difficult for me. So hope you enjoyed today's session, everyone. So thank you for your words. If you have any queries, any doubts, please go back. Please try to understand. If you have any difficulty, we can again discuss this forward propagation, and we'll try to understand the backward propagation, then activation optimizer, everything we'll try to go and discuss here, right? And we'll build our own architecture as well. We'll try to showcase practical implementation as well. All right, guys, then if no further questions, I will dedicate 1 more minute. If you have any questions, any doubts, please let me know. And then maybe we'll try to close the session for the today. So hope everyone, guys, don't forget to mark your attendance. So Amar, please once again share the link, because I'm not able to copy paste here. Thank you, Monica ma'am. Thank you, Sony. Thank you. Vanaja, thank you. Yogesh sir, thank you. How to start an input variable to start with? Input variables, sir, will be based on your data only. I'll explain that. I'll explain that in coming session. Apart from that, guys, any question? I hope I am taken all of your questions. Sony Sheikh, thank you. Guys, Samar has sent the attendance link. Please make sure that I request everyone to mark your attendance. It is mandatory to get your certifications, okay? So don't forget to mark your attendance. Hope you enjoyed your session today. So we'll try to conclude here, and we'll try to continue tomorrow as well. Thank you, Monica ma'am. Thank you for your kind words. Disha, thank you. All right, guys. So if no more queries and concerns, then maybe we'll try to close the session then. Yeah, I will cover what kind of things we'll try to cover here. Dharma Kumar sir, thank you very much. PPT will upload to guys. PPT will upload. Thank you very much. PPT will upload to LMS. Don't worry. This entire PPT will be available on LMS. Everything will be available. Don't worry about it. All the material PPT, whatever the files, Jupyter notebooks we're gonna take, all this will be available in LMS. Anjali ma'am, thank you. Rafi Ahmad sir, thank you. Yashan Kumar, which algorithm to use in NN? Algorithm, there is no such algorithm, sir. ANN is the algorithm only. So ANN is the algorithm only we'll using, but the models will be different. So the ANN will be trained on different architectures. That what we'll be using. So I'll show you that. ANN itself is algorithm, and the way we try to utilize that ANN will be called as different models, different model architectures. Right? So the basic algorithm is ANN only. Hope I answered your question, sir. All right, guys, thank you very much. I really liked your session today, because the kind of enthusiasm and participation is really awesome. I request everyone to keep up the same, and hope we'll try to make the sessions more exciting. All right. So finally I will give a thank you very much, and let's close the session today then. All right. So Amar, thank you. You can close the session now.
Yeah, sure. I will take few questions if they have regarding to the LMS, and then I will wind up.
Yeah, sure.
So dear participant, I already shared the attendance link a couple of times. I'm sharing that once again. So please make sure that you are marking your attendance and filling the feedback about the session as well, because 60% attendance is mandatory to get the certificate of participation. And if you are struggling anywhere regarding to the LMS, you have any query or question, yes, please ask me. I will help you on the same. Link doesn't open. It's opening to all. Most of participants are already fit. You just copy paste. That will work. So Aisha, you can just go through the store option and you can enroll there. Definitely that course will be with you. Okay, I think there is no any more question. So dear participants, thank you so much for joining today's session, and we'll see you tomorrow at same time. So bye bye, have a nice day.
Yeah, thank you very much, and thank you, Amar, guys. See you then tomorrow.
Yeah, bye.